We've talked about graphing from vertex form, and now we're going to look at how to graph from something that's in standard form, which, remember, is just already in that form we used when we were talking about factoring. So I've got ax squared plus bx plus c. There's no parentheses. My terms are in order, squared, and then first degree, and then the constant term. And we spent a lot of time identifying a, b, and c so that we could factor, but they're also going to be useful here because the vertex I can get the x value by solving for this negative b over 2a. This is also going to give me the equation for my axis of symmetry. It's going to be really useful. Okay, so when we get ready to actually start graphing, so the first thing we're going to look at is the x value of the vertex, which is also the axis of symmetry. So we're going to use x equals negative b over 2a. Okay, so when I look at my equation, I need to make a list. A is 3, b is 6, c is negative 1. I need the 3 and the 6. Now what's important is that we pay attention to this negative that came with the formula. So I'm going to leave negative, open parentheses for b, and 2 times a, and we're going to fill those values in based on what we wrote down. So my b value is 6, my a value is 3. So when I simplify that, I've got negative 6 over 2 times 3 is 6 equals negative 1. So I can immediately go over to my grid and I can go ahead and sketch in my axis of symmetry where x equals negative 1. Okay, so I have my x value. We're going to plug that straight into the equation to find the y value of the vertex. So I'm going to use 3. We're going to put the negative 1 in for x squared plus 6 times the negative 1 we're going to put in minus 1. Put negative 1 in, negative 1. Okay. 3 times negative 1 squared. Remember, that means negative 1 times negative 1 is positive 1, times 3 is 3, plus 6 times negative 1 is negative 6, and if you want to just write 3 minus 6, that's fine, minus 1. Negative 6 minus 1 is negative 7, plus 3 leaves negative 4. So this is the y value of the vertex. So I'm going to follow my axis of symmetry down 1, 2, 3, 4, and I have my vertex here. That ordered pair is negative 1, negative 4. Okay. The other nice thing about standard form is it gives me the y-intercept right off the bat. Okay, c value is always the y-intercept. Okay, we could come back and just write it in right here, y-intercept. Because when I look at my original formula, negative 1 is the y-intercept. A lot of you noticed this when we were graphing that very first day. Y-axis, negative 1, there's my y-intercept. And then we're going to do the exact same thing we did with vertex form. I'm going to reflect that point across the axis of symmetry. And now I can draw our parabola. Sketch it in, just don't make it pointy. Okay? I need 3 points to make a curve. 5 would make it nicer, but those 3 are enough to do it. I have successfully graphed 3x squared plus 6x minus 1. Okay? We'll do one more. So now we're going to look at negative 3x squared plus 6x minus 5. So I'm going to label A, positive 6 is B, negative 5 is C. Okay, and we're going to follow the same steps. So first, x equals negative b over 2a. So negative, plug in b over 2, substitute in our a value. B is 6, a is negative 3. So when we solve that, I get negative 6 over negative 6, which equals positive 1. So there's my axis of symmetry, and we're going to sketch it. Okay. And then step 2, we're going to take that x value and sub it back into the equation to get our y value. So negative 3, substitute that in, plus 6, substitute it again in, minus 5. So we're going to take our 1. Okay, 1 squared is 1 times negative 3 is negative 3. Plus 6 times 1 is 6, minus 5. Again, I'm going to do the negatives first. Negative 3 and negative 5 is negative 8. Plus 6 is negative 2. So the y value of my vertex is negative 2. So back on the axis of symmetry, negative 2. And we can write our vertex 1, negative 2. Axis of symmetry, we can fill in x equals 1. Okay, go get my y-intercept, which is always my c value. Negative 5, 0, 1, 2, 3, 4, 5. Reflected across. And I've got my parabola. Okay. Now we're asking you to look at the domain and the range. Okay, remember the domain of all parabolas, because they never stop moving to the left and the right, is all real numbers. Or we can write negative infinity, less than x, less than positive infinity. And the range, we're always thinking from the bottom to the top. So if I look at the bottom of this function, it's at negative infinity. And the top of it, the highest point, the maximum of this graph, is at negative 2. Okay. We can write out the whole thing, or we can only focus on the part with the actual numeric value. This says y is less than or equal to negative 2. So basically I can use anything I want, infinity, as long as it's less than or equal to negative 2. Okay. So you try this one. Following the same steps. You can pause the video and do it now, or you can wait till we're finished with the end, but you're going to do this one on your own. Okay? All right, writing equations. This is the same process that we went through with vertex form. We're actually going to go through vertex form to get to standard form. Exactly the same process. Okay? So we're given the vertex and a point. So with our vertex, we're going to think of this as h and k. With our point, we're going to think of it as x and y. And we're going to start with vertex form. Y equals a times x minus h squared plus k. And then we're going to sub in the values that we have. Okay? So y equals a. The first thing I'm going to plug in is x minus the 7 plus negative 5. And we'll clean that up a little bit. Y equals a times x minus 7 squared. Let's just make this minus 5 so it's a little neater to look at later on. Okay. And then we're going to add in the x and y value. So I'm going to go grab this x and this y. So negative 17 a times, now I need the 9, minus 7 squared minus 5. And at this point, we're going to go ahead and solve. Negative 17 a times 9 minus 7 is 2 squared minus 5. Negative 17 equals a times 4 minus 5. Add 5. Negative 12 equals, and I'm just going to write 4 times a because it's the order we're used to looking at it in. 5 by 4, a equals negative 3. So then I'm going to take that negative 3 and I can write, substituting it into the vertex form, y equals negative 3 times, and we come back to this step up here where all we plugged in was the vertex, x minus 7 squared minus 5. So this is vertex form. Okay. To convert from vertex to standard form, we just follow the rules of algebra. Okay. So we always are going to have this squared term right here. We need to multiply that out. So I've got 3 times x minus 7, x minus 7, and then minus 5. Okay? So I like to do this part of the multiplication first. Okay, we'll do the repeated distribution while the numbers are as simplified as they can be, and then we'll worry about distribution. You can distribute first and then do the binomial multiplication. To me, I like to do this part first. So we're going to keep the 3, and we're going to open parentheses. X times x is x squared. X times negative 7 minus 7x minus 7x. Negative times negative is positive. 7 times 7 is 49. And then we're going to bring the minus 5. Okay. Now I want to simplify this before we distribute. 3 times x squared, negative 7 plus negative 7 is negative 14x plus 49 minus 5. Okay. Now we can distribute that 3 to everything in the parentheses. Okay. And when we do that, 3 times x squared is 3x squared. 3 times negative 14 is negative 42x plus 3 times 49 is 147. Bring down the minus 5. So the last thing we need to do is simplify one more time right here. So we've got 3x squared minus 42x, 147 minus 5 is plus 142. Here is our standard form. Okay. It's tedious. There's a lot of steps. But try this last one on your own before you come in.